Hello guys, welcome back to Maison African Motives, still on Mechanotechnics N4, working on the precision measurement. So we are given here the question paper of March 2023, where we're given Fig 1, which shows a tapered ring gauge. Okay, so this is a tapered ring gauge that is checked by accuracy by means of two precision balls. So we have got the two precision balls here. All right, so we are given that. Okay, let's just increase so that we see properly here. So this is the first part of the question where we are given, use the dimension given on the diagram and calculate the included angle of the ring gauge. Okay, we need to calculate the included angle of the ring gauge in this case, okay, which is the angle theta between here. So what we are going to simply have, we need the angle taken. We can check it from the point here, from this point. Okay, so we are going to have, if we have got something of this nature here, this is where we are going to have the angle that we are referring to as theta, which is the one that we see on the other side also as theta. So this is the angle that we are supposed to have. But how can we get about this to calculate this angle with this information? Okay, whenever you are dealing with a tapered ring gauge, this is what you're going to do to calculate this angle. From the dimensions that you have, we have got from this inner circle, from this smaller circle to the upper circle that we have on top here, we have got a distance that we are given in between. Take note here to the top, and also the distance in between here. This distance in between, this is the one that you're given as 4,25, which is in millimeters. Okay, so what you're going to do is to join this part. Okay, let me just have my ruler so that I can have something that is a little bit accurate to what I want to explain. All right, so here you're going to join from the radius. Okay, I'm going to join these radiuses together. All right, so let me just try to push this. I'm going to join the radius of this first circle. All right, this is what I'm going to do here. Join the radius of which is already joined here. Okay, so this is what you're going to have, the radius. Then if you consider each radius to the circle, okay, that is the radius to the circle, meaning to say we have got a tangent. Okay, this is the part that is represented here. If you take the radius to the circle, we've got a tangent which meets at 90 degrees. Okay, so this is what you have here, the radius, each part to the circumference of the circle. We formulate 90 degrees with the tangent. The same thing here, the radius to the circumference, formulate 90 degrees. Okay, so if we are to join, let's say we want to have this distance here, I'm going to present this on a separate diagram, what I'm explaining here. So we need to find these points. Okay, let's say this is my point A. I'm going to have my point A, my point B. Okay, let me put my point B here according to my sketch that I made. This will be my point B, and this will be my point C. Same, I can have this on the other way. I can have another point here. So since we are to calculate this angle, I'm going to separate this into two. I'm going to calculate from this side, this theta, and this is will be another theta. And these two, they are equal. It's actually one and the same. These are congruent figures. So you're going to calculate from this triangle, this theta. Don't worry about this A, B, C that I'm showing. I'm going to show you how do you actually calculate this, okay? So from your constructions, this is supposed to be, this is taken at 90 degrees. Okay, so we're going to take our B a little bit inside. This is a little bit inside here. Okay, at 90. So on your sketch, you shall have this as, okay, I'm going to have this sketch that is going to be represented that you're going to use to calculate theta. These are the stages that you're supposed to follow, guys. All right, so here you shall have, let me have it this way. Okay, we take this to the ground. So I want to take this to the ground, back to the ground here. Okay, so that we can have our point like this. All right, so if we take it this way, let's say at this point and back to this point. Okay, I'm going to explain later on what this part means here. We take it back to this point. I'm just going to formulate a triangle. I'm going to explain this triangle, guys. Don't worry. Okay, so this triangle is the one that we are going to use to calculate the first theta. All right, so let me join also this other part. All right, so from this triangle, we can join to this part here like this. Okay, let me remove this. If you are to check here, guys, I presented, it's only that here, it's not accurately done. I want to present from this point A. This is my point A to the point B to the point C. Okay, so this is supposed to be at 90 degrees, direct at 90 degrees, all right? At 90 degrees, and this is our theta here. This is our theta. So what you need to calculate is this theta. From these dimensions, it follows that, remember, you are given our diameters here, which is the diameter and the second diameter. Okay, so in order for you to calculate the distance, so these are the formulas that you need. Okay, I'm going to, okay, let me present before the formulas. So this is this distance here from this point here. I'm going to present this as my x, all right? And from this point up to this point here, I'm going to present this as my y. So this is my x and this is my y, okay? This our x here, okay, from this point up to this point, and this is our y. Then from the bigger circle, we are going to have the diameter. From the bigger circle, we are going to have the radius of the bigger circle. I'm going to represent as r. Then the radius of the smaller circle as small letter r. Okay, so take note of these letters. These are the ones that I'm going to use to formulate our formulas to calculate AB and to calculate this side of AC and this side of BC. Okay, it's not just my sketch is not that accurately done, but this is what you're going to have. Okay, so our AC is going to be taken from, we add these two, that is from X to R. That's we add the X, this distance, to the radius R. So it's going to be XR like this, X plus R minus Y plus this distance of the radius of the bigger circle, which is R. So remember, this radius is the same also from this point to this point here. From this point to this point is also R. So we are going to have it as Y plus R, okay, subtracted from X plus this radius of the smaller circle. So this gives us AC from A to C. Okay, so take note, this is 90 degrees. Don't worry about my diagram, guys. It does not make sense. Okay, so our X, that is the bigger one in millimeters. Our X here is 36. So that's 36.75 plus the radius of the smaller circle. That is small letter r here. So take note here, we are given the diameter of 20 millimeters, meaning to say our radius here is diameter over 2. That's 20 over 2, which is 10 millimeters, all right, millimeters. The radius of the bigger one is diameter over 2, so it's 30 divided by 2, which is 15 millimeters, all right? So this is what you're going to have here. So I'm going to have r here, the small letter r, which is 10, minus y plus r, that is y here is this smaller distance, 4.25. That's 4.25 plus the radius of the bigger circle, which is 15. So you're going to add 15 like this, okay? So this gives us AC. So AC is going to, from this part, we are going to obtain 46.75 minus this, which is going to be 19.25. All right, so we are going to obtain our AC as 27.5 millimeters in this case. Okay, so like I said, we are going to have our AC here, that's 27.5 millimeters. Then also we can calculate B to C. So B to C is the difference between the radius, the bigger radius and the smaller radius, okay? So B to C is taken from this formula, the R minus R like that, okay? So our BC, the bigger radius, which is 15 of the radius of the bigger circle minus the radius of the smaller circle, which is 10. So this is going to be 5 millimeters, okay? So meaning to say here we've got 5 millimeters. Okay, so with the 5 millimeters and the 27.5 millimeters that we have, we can be able to calculate the theta. So like I said, please guys, look this properly. This is a right angle triangle. Don't look at my diagram the way it looks like. Okay, so this is a 90 degrees. So according to theta, this is your opposite and this is your hypotenuse. This is according to 90, opposite and hypotenuse. So which ratio uses the opposite and hypotenuse at the same time? That's from our soccer tour. It is the ratio of sine opposite of hypotenuse. So the sine of theta, if it is equal to the opposite of hypotenuse, that means the sine of this theta is equal to the opposite, that is 5 over the hypotenuse of 27.5. So from this, we can calculate theta. Theta is going to be equal to the arc sine of 5 over 27.5 like this, which is simply from your calculator, shift sign. So shift sign, you plug in your values direct. So this is going to give you 10,476 to 3 decimal places. Okay, so which we can write to 2 decimal places, which is going to be 47 or just 476, depending with the degree of accuracy that you are given. All right, so this is how we can calculate this angle here. But I remember what I said is that this is a combination of 2. If you check properly, that's our theta here and our theta here, which gives us the whole angle that we want, which is 2 theta. So we are going to multiply or to add theta plus to obtain the whole of this angle here. So from this theta that we got, therefore the included angle is going to be equal to, so therefore here, therefore our included angle is going to be equal to 2 times this angle, 10,476 degrees, because we calculated one of the thetas that were given. So this is going to be 20,952 degrees. Okay, so this was the included angle. These are the stages that you use to calculate the included angle whenever you are given a tapered ring gauge like that. This is the sketch that you can use and the formulas that you are supposed to apply. Okay, I think this is direct. You just need to know your formulas, how to apply your formulas like this one. Okay, so we had the other part of the question, which was on 2.2, which we're given fig 2 shows a juvetal with 2 identical rollers of diameter 25 millimeters. Okay, so this is a diameter here of 25 millimeters, also on this side a diameter also of 25 millimeters. We are asked to calculate the distance, that is x. Okay, calculate the distance x if both angles of the juvetal is or at 65 degrees. That's here we've got a 65, and also here we have got a 65 degrees. Okay, so let's just try to separate our sketch in this case. Okay, I'm just going to try and separate this sketch in a way that we can understand in this case. Okay, so if you are to consider from our sketch here, we want to calculate this distance x. Okay, so this x, what is it made up of? Let's check what is making up this distance. Okay, from this x point here up to this point here. Okay, if you are to consider properly, let's say this is our point A. I'm going to mark this as A. And this is my point B, from this point to this point, okay? Which is the same also, okay, no, okay, now I'm confusing with this, sorry guys, not to this point here, to this point, not the 35. The 35 is just giving us the distance. Okay, so I'm going to mark up to the end. Okay, let me just put a ruler, guys. I hope it is not going to affect us. All right, so let me present it this way so that we might understand what I'm trying to say here. Okay, that's a 90 here. All right, so I'm going to put this at this point here, my B at this point. Okay, so let's have our B at this point. All right, which is the same as from this point to the end here, from this point to the end. So I did this question another way, so I'm just going to explain this in another way again. So these two, they're actually the same. From this point to this point, it's same distance from this point to this point. So let's just say this is AB. So I'm going to write this as AB. So since this is the same distance, I'm going to also write this as AB. Okay, so it's another way you're going to understand this one maybe much better than the one that I did in another video. Okay, so this is what we have. Okay, from A to B, from A to B also, we are saying this distance is the same. All right, then in between here, we are going to see that we are going to remain with a certain distance in between from this point up to this point here. There's a distance that is remaining from this point up to this point. All right, this distance here from this point up to this point. Okay, I'm going to leave that part for now, but this is what we have for now. Okay, then this distance is included in this 125. So that's why I'm not talking about this, but this part we need to know about this from A to B. Okay. Also, there is a distance that we have from the point here. Okay. We talked about A to B. Okay. Then if you consider just from the radius here, from this point of the circle, the center, okay, to this point at the end where we have our X, that's our radius. Here we've got a radius, okay, from this point up to this point, that's a radius, which is the same as from this point here up to this point, a radius. Again, from this point up to this point, we've got a radius. Okay. So with this information, okay, we included the radius. We are left with this distance. Also, mark this distance. Okay, very soon you're going to understand me. Then you mark from the center, that is our center here. Let's just say from up to this point to this point at the end where we have got a B here. Let's say this is C and this is our D. This distance here, it's different from this one. It's different from A to B. A starts from this point, but this one starts from the radius to this point. So if you consider these distances that I have marked here, I have considered everything that is there. So this is my CD again. This is from C to D, from C to D. So if you consider these distances that you have, they include or they add up with X. So with these distances, you are going to see that X is going to be taken from this formula. Our X is equal to, if you check here, we have got 125. If we subtract these A and B, if we subtract A and B, we remain with this part from this point C to D. If we subtract from 125, okay, let me write it like this. 125 minus the AB that we talked about. So there are two of them. So I'm going to subtract the 2 of the AB. This is another way that we can answer, or another formula from that one that I explained from another question paper. Okay, so I have removed A and B, meaning to say I am remaining with this part from D to C, which is part of this 125, which means it's there. So this part here, this one is remaining. Okay, now if I add from C to D and also this radius, it means I'm having the X at the end because I removed A and B. So I'm going to add the 2 radius, that is this radius and this radius. So I'm going to add the 2 radius. Also, I'm going to add from this C to D, that is the 2CD like this. If I can add these 2, then I have my X at the end. All right, so how is that possible? Where can we obtain AB? That is the question. Where can we obtain our AB? Okay, from our sketch here, we can use any part, but here, if we check here, I'm going to extend so that we can properly see from our diagram, how can we obtain our AB? All right, if we check here from A to B, this is the one that you want to calculate. We said there is an angle of 65 degrees, which is the same here, 65 degrees. So this angle of 65 degrees is the one that we can use to calculate this angle or we can use it to calculate this angle at this point. Why? If we check, this is a horizontal line. So this line and this line, they are parallel lines. So if this angle is 65 degrees, it means also this angle is going to be 65 degrees. Or you can use the concept of 90 degrees. This angle here at D, it adds up at 90 degrees. So 90 minus this 65, we obtain this angle that is remaining on D, which is going to be 90 minus 65. That's something like 25 or 50. Okay, so we are going to calculate this remaining angle here, or you can use the 65, or this is going to be exactly 25. Okay, so now with the 25 degrees or with the 65 degrees, we can calculate from A to B. That is from our trigonometrical ratios. Remember that from our trigonometrical, here I'm going to use 65. Okay, let me use 65. Then you can use also 25 if you want. Okay, so according to 65, this side 35 that you see is the same as this. This is the side 35. So here it's opposite to 65. So this is opposite. So you've got opposite here. Then AB, this one, remember this is 90 degrees. So AB, according to 65, is adjacent to with this one 90 degrees. So this is your adjacent side. So which ratio uses the opposite and the adjacent at the same time from our soccer tower? Remember, from our soccer tower, we need adjacent, opposite, and adjacent, that is tan. So meaning to say that tan of 65 degrees, the angle that you are given, is equal to the opposite, which is this side of 35. So it is opposite 35 over the adjacent, which is the AB. So this we can calculate AB. All right, so cross multiply, that's AB, tan of 65 degrees is equal to 1 times 35, which is 35. So to determine AB, simply divide by the tan of 65 both sides, divide by the tan of 65 both sides. So we've got our AB in this case. So this can cancel. So AB is 35 divided by tan 65, which is going to give us a decimal of 16,321 millimeters. Okay, so here we have managed to determine AB, which is the same as this AB that we have. So this is 16,321, same with this part, 16,321. Okay, we have calculated AB. Like I said, we could have calculated this from the 25 degrees. So from the 25 degrees, AB is now opposite and this is now adjacent. So we are going to use it as tan. It is going to be tan 25 this time. Tan 25 degrees is equal to AB, which is now your opposite. So it is going to be AB over the adjacent, which is 35. Then you can cross multiply to obtain AB. You still obtain the same answer. Okay, so we are done on AB. Also, here we need to calculate CD, the radius. We can calculate from the diameter because we've got the diameter already. So the radius we have, but we do not have CD. So we are going to calculate C to D. Okay, C to D, depending with the triangle that you're going to take or which part you're going to take. In this case, I'm going to use it from this triangle. Okay, let me use this space here so that we can calculate CD. Remember, C to D, that is this part here from C to D. Okay, let's say we joined from the center of the circle here, from the center to this point at C like this, from the center to C, then to the point D like this. This is what we want to calculate. Okay, if we are to join this part, we are going to see that this point or this part that we are formulating here is a right angle triangle. So here we are formulating a right angle triangle from C to D to the center, which is our O. So we are formulating a right angled triangle like this. All right, so this is what we are formulating, a right angle triangle. This is our C, this is our D, this is our O, which is the origin or from the center. So from O to D, it represents the radius. From O to D, that's the radius. So here, that's the radius from O to D. And our radius, we can calculate from the diameter of 25 millimeters, diameter is 2, that's radius is 2, d over 2, which is 25 divided by 2, which is 12.5 millimeters. So that means we have the radius here, which is 12.5 millimeters, like this. Then we can calculate this angle in between. Remember, the whole of this angle is 65, which means this whole angle here that we see is the one that is indicated here. They just indicated at the outer, but they are indicating this angle. So this divides our angle into 2 equal parts. So meaning to say, if this was 65, it is divided into 2 equal parts now. So you are going to have 65 degrees divided by 2, which is going to be 32.5 degrees. So this is the angle that we have inside this triangle, which is 32.5 degrees. So with the side of 12.5 and this angle, can't we calculate the side CD? Yes, we can calculate this side from our trigonometrical ratios, okay? So let me just remove this. So from our trigonometrical ratios, we can calculate CD because according to this angle, this is your opposite. Here, this is your opposite, and this is your adjacent. This is adjacent to 90. So which ratio uses opposite and adjacent from our SOHCAHTOA mnemonics? Which one uses opposite and adjacent? We are back again to tan. So that's the tan of theta, which is the tan of 32.5 degrees is equal to opposite over adjacent, and the opposite here is 12.5 over the adjacent, which is CD. So this can help us to calculate CD. This is same as over 1, so we can cross multiply. That's here. CD times tan is going to be CD tan 32.5 degrees, which is equal to 1 times 12.5, which is 12.5. So to find CD, we can simply divide by the tan of 32.5 both sides, by the tan of 32.5 degrees both sides. Okay, so this cancels. We have our CD in this case, which is using our calculator. We can simplify this value. Okay, so if we simplify properly from our calculator, our CD is going to be 19.621 millimeters. Okay, so with this information, like I said, from the formula that we formulated here, we can now substitute our values. We have calculated AB here. We have the radius, we have our CD. So you can simply substitute. This is a direct formula than the one that we had previous. If you still remember this question, we had a question like, but only that the dimensions also they changed and so forth. So if you check with that question, with this method that I'm explaining, you might wonder to say what is happening exactly. So this is another way that you can answer this typical question. So this is going to be 125 minus 2 times AB. Our AB in this case, we got 16.321. So that's 16.321. So that's minus 2 times 16.321 plus 2 times the radius. Remember the radius from our diameter, radius is 12.5. So we are going to multiply by 12.5 in this case. So this is 12.5 plus 2 times CD. Our CD we calculated here and we got 19.621. So this is 19.621, 19.621 like this. Okay, so this gives us the length or the distance X that we are given in this case. Okay, so if you simplify properly, you are going to obtain 156.6 millimeters in this case. Okay, so as you can see, this is a direct formula that you can use whenever you are dealing with this type typical question, but you must be careful on your calculations, but it's a direct formula. So I just introduced this method so that you can compare with our previous method that we did from another, now I can't remember the question paper, but if you still remember, we did a question which works with the 2 identical rollers like this, and you're asked to calculate the distance between, if you still remember that. Okay, but can actually use that method again. So you can use that method to prove that are we having the same answer just like the previous part. Okay, but that's it, guys, from Mason African Motives. till we meet again.